Hello again, this is Jim Caffey, and today we are going to do chapter 26 on galaxies. Here we see a spiral galaxy, also known as the fireworks galaxy. As you can see, it has lots of star-forming regions, gas and dust. Our friend next door, the Andromeda Galaxy, also known as M31, with at least 2 satellite galaxies and over 400 billion stars. Now, Edwin Hubble was born about 20 minutes away from me in a town named Marshfield, Missouri. There is an interstate with schools and buildings named after Hubble, and they have a 1/3 scale replica model out of stainless steel of the Hubble Space Telescope on the town square where Edwin Hubble was born, in Marshfield, Missouri. Spiral galaxies. Here we see a face-on galaxy and an edge-on galaxy. Barred spirals have this bar going through the core in the middle, and your spiral arms come off those bars. The Hubble classification of galaxies is very, very important. Very important here. So, we have the ellipticals. These are big, old stars, not much gas and dust. And then we have the 2 spirals, and they have lots of gas and dust. Now, there are other classifications, but these are the 2 main ones. And the ellipticals go from a category E0, meaning they are circular or spherical, to an E7, which is pretty flat and elliptical. The spirals go from basically an SA or SBA for S spiral bar. They go SA with a big core and tight arms to an SC or even an SD with very loose arms spread out. Elliptical galaxies have a bright core, a diffused outer part. This is the dwarf elliptical galaxy M32, a component of the Andromeda Galaxy that we saw a minute ago. Here is the 4-meter telescope in Chile. I have used the 4-meter telescope of that kind in Kitt Peak National Observatory outside of Tucson. So this one is M101, the Pinwheel Galaxy. I think it looks like a hurricane. We see Cepheid variable stars, those that pulsate, and they get brighter and dimmer on the order of a few days. And we can find Cepheids inside other galaxies, which is one of the purposes that the Hubble Space Telescope was even built and put into space, was to look for these Cepheid variable stars in other galaxies to see how far away they were. We can see type 1A supernova, which is that bright object there. Stars don't actually have those spikes on them. That is an artifact of the telescope. Here we see Vesto Slipher, and he spent his entire career at Lowell Observatory, where he discovered the large radio velocities of galaxies, how fast they're moving away from us. This was, Himmelson was Hubble's collaborator on a lot of his observing, measuring, and classifying the galaxies. We see here that distance and velocity of that recession of that galaxy, how fast they're moving away, shows us Hubble's data and Hubble and his collaborators' data, Himmelson. If we take a ruler and we stretch it out, we see a distance those ants move on that ruler proportional to how fast it's being stretched out. You stretch it out more at the end, you go further out. And so galaxies that are way out in the universe are moving exceedingly faster away from us than galaxies near us. And we talk about this expansion like a loaf of raisin bread. So you have a raisin bread and you have the raisins inside of it, and it's expanding and getting bigger, and those raisins at the edge get further out than those in the core. You can also think of this as a balloon. Take a balloon and stretch it out, blow through it, and you'll see those dots on the end moving out faster. That's going to do it for chapter 19. Excuse me, we are on 26. Chapter 26, yes. And we'll see you for the next 4 coming up. Thank you. Well, did you enjoy that episode of 10-Minute Astronomy? If so, check out all the other videos in that playlist for 10-Minute Astronomy and other videos on my channel, and then hit the subscribe button right there. Thanks.